Man and nature, a continuous dance of danger. In the middle of the North Sea waves, one will find a model of human ingenuity and perseverance. Ekofisk, a city of steel, a complex gathering the Earth's nectar to quench the thirst of our economy. In spite of the unrelenting attacks by the sea, man appears to have won the struggle against nature. At least, it seemed he had. Until it was discovered the entire immense complex was slowly sinking below the waves. If the waves would reach the upper structure of the platforms of the complex, it would mean the end of Ekofisk. Far below the bottom of the sea, at a depth of some 3,000 meters, the oil-bearing limestone was being compressed by the enormous weight of the Earth on top of it. As a result of the intensive extraction of oil and gas, the pores have lost their natural resilience, and that meant that both the seabed, with Ekofisk on it, were sinking and will go on sinking. Ekofisk is the heart of oil production on the Norwegian continental shelf. From Ekofisk, about 350,000 barrels of oil a day are pumped to the mainlands of Norway, Germany, and Great Britain. This huge economic interest necessitated the rescue of Ekofisk no matter how. The complex consists of 8 platforms and a storage tank interconnected by bridges. After a number of investigations, Phillips Petroleum Company Norway decided Ekofisk had to be raised by adding 6 meters to its substructure. But there was one complicating factor. The interconnecting bridges were packed with piping and cabling which were linked to the platforms. Taking the whole complex apart and putting it back together would take far too much time, and the cost unimaginable. The only solution, jacking up the entire 40,000-ton complex in one go. The tank could not be raised. Here, the links had to be disconnected. The hotel platform is a self-supporting unit, so the platform could be raised separately. The same applied to the riser platform. But how does one jack up 6 platforms by 6 meters in one go? The solution was offered by the French engineering bureau TPG in close cooperation with Rexroth Sigma France and Hydrodyne in the Netherlands. Fix hydraulic cylinders to the substructure of the complex. Cut the supports and fit flanges. Jack up all platforms, including the link bridges, at exactly the same pace. Put in extensions. Fit flanges, and Ekofisk will be saved. It sounded fairly simple. Reality was a little different. Through its subsidiaries Rexroth Sigma and Hydrodyne Systems and Engineering, the Mannesmann Rexroth organization was commissioned to complete the plan and quote for the execution of the project. The wide offshore experience of Hydrodyne played an important part in this. It was an open design, so many tough technical nuts had to be cracked.
Put a cross here.
This is just a kind of, let's say, artist impression or something. It's not
Calculation upon calculation, and the result, on the appointed date, the quotation. A swift decision was made. The Mannesmann Rexroth Group was contracted. The Dutch company Hydrodyne would bear the main responsibility for this project, the biggest in the company's history. A whirlwind passes through the Rexroth companies. At Hydrodyne, a separate division is created. Part of the company takes on Ekofisk. Immediately after the signing of the contract, production starts. Only 12 months. For each employee, every minute counts.
How should it look like? Where are the connections? What's the relation between
Make sure that it is returned this afternoon. No problem for
The Mannesmann Rexroth Group is fully equipped for big and demanding projects. 120 rough cylinder shells and piston rods were produced by Mannesmann Röhrewerke, Mannesmann Anlagenbau and Mannesmann Demag. In this Dutch factory, the cylinders resurface as beautiful custom-built hydraulic units.
Is it now finalized?
It is finalized.
So rock bottom solid, no problem?
Rexroth Law, the world's largest manufacturer of hydraulic components, supplied the ingenious heart of these units. The ultimate responsibility for the project lay with Hydrodyne. Hundreds of hydraulic power units were co-manufactured by Hydrodyne and two other Mannesmann Rexroth companies, Rexroth Sigma in Lyon and Rexroth Norway. Besides the hydraulic cylinders and power units, the order included designing and manufacturing some 7,000 meters of hydraulic pipes, which obviously had to be checked, double-checked, and checked once again, centimeter after centimeter and joint after joint. When in operation on the North Sea, any imperfections would cause major technical troubles.
The total planning doesn't show much flexibility. We are on schedule, but there isn't any...
A special measuring system was built into the hydraulic cylinders. With this system, the position of the piston rod could be determined with an accuracy of 1/10 of a millimeter over its total displacement. Hydrodyne works for this project according to the demanding offshore quality standard NS 5801. Phillips Petroleum takes no chances. At Hydrodyne in Boxtel, two special test benches were erected on which the hydraulic strongmen were put through their paces one by one before they were allowed to leave the factory. The vertical testing of the cylinders was also done here. Similarly, the hydraulic power units were test tortured before the reports were initial. An enormous simulation test bench was installed at Rexroth Sigma in Lyon. Here, all functions of the hydraulic system were tested on a true-to-life scale. Here, all activities which would take place offshore, such as raising the platforms, were simulated. Under the supervision of Hydrodyne, the French company Comsip was assigned the manufacturer of the elaborate and very special computer control system. The synchronization control came from Rexroth Sigma. All cylinder movements are controlled and checked by the computer network. The entire computer system was tested at this French location. April 1987. 3 months to go before the raising of the first platform. The production in Boxtel and other Rexroth plants is nearing its completion. The hydraulic power units have been paired off and in their offshore structure are ready for transport. The Hydrodyne cylinder factory looks as though it's painted red by the huge number of cylinders almost ready to confront the salty waters of the North Sea. Some 500 kilometers away, an international crew is preparing for the assembly of all that equipment. Like spiders in their webs, the crew hangs below the platforms. Delft Sail has been chosen as the port of departure for the thousands of tons of equipment needed for the great hydraulic jackup. First shipload on its way to Ekofisk, the place where a few months from now, history will be made. Attention is shifted from land to sea. This is where the action is, amidst the waiting waves of the North Sea. The hookup operation is in full swing. In the course of the project, this operation has added a number of responsibilities to the task of Mannesmann Rexroth. The specialists of Hydrocare, the Dutch service division, are responsible for the installation of the hydraulic equipment, the electric wiring, and the installation of the computers.
Between 0.4 and 0.74. A1. Remember A1 was the one that we had about 4 millimeters difference between Jack 1 and Jack 2, which was the initial.
The moment for the hydraulic installation to prove its qualities has come. Controlled by computers, the hydraulic cylinders exert such pressure on the bottom of the platform deck that the weight of the platform is no longer supported by the upper part of the platform leg, but by the cylinders. The flame cutters can do their job. The first leg is cut, and the flanges are put in place.
And there is a check on the moment from our
In
first man
Broxtol,
sitting
the
off
project team is arranging the final component transport. Everything is under control. Then, a sudden storm hampers the work. The time schedule is getting tight. This type of wave shows why Phillips is justified in pressing hard. But Lady Luck offers a helping hand. For exactly at the moment planned, nature holds its breath. For 24 hours, just long enough to ensure the success of the overture to the great hydraulic jackup.
Did you copy that, Rupert? Yeah, I think I must be able to see about Newcastle from where I am. Well, I can see Texas from here.
You would.
The hotel platform proudly towers above the others. The riser platform is also raised successfully, but it is the jacking up of the south branch, 4 platforms to be raised at one go, everyone is waiting for. Ekofisk lies peacefully, but deep down inside it is whirring. The beating of its heart is almost audible. Minutes are ticking away.
Negate one area too.
The final checks.
Tom, I've listened to the various area checks here. Are you happy that we're okay to go?
Yes, I believe so.
Okay, let's start the elevation.
The operation is underway. The great hydraulic jackup will become reality. Thanks to perfect preparation and training, this at times looks like a routine job.
Okay, we'll move on to leg A4 now, okay?
Night falls while Ekofisk majestically ascends to its final destination. Then the highest point is reached. An army of workers crowds the scaffolds to place the extensions in the 6.5-meter gap. The bottom flanges are secured. While day dawns over the North Sea, the final chord of the hydraulic installation is played. Back to the nerve center to have Ekofisk descend gracefully onto its extended legs. A major pillar of the European oil and gas industry is saved.
All the best. Cheers.
Skull.
GOD Central.
Don't keep calling me, we're drinking our champagne here, the bubbles are going out of it.